going to talk about indispensable ingredients for a secure IoT product as I see it myself. So I'm going to start by putting some of my experience into context. I've been working for about 30 years in telecommunications, and then the last 7 years, IoT security in particular. While at telecommunications, there's an awful lot of security involved with backhaul security. So I'm going to start by going right back to one of my earliest experiences, which was my father dropping a fast Fourier transform program, which was about 3 inches of card on the carpet in front of me. I'm not quite sure who was to blame, whether the rubber band broke or not, but he hadn't numbered them. Anyway, this brought to light really importance of integrity, in particular computer programs. And the simple way for cards was to draw a red line, a diagonal red line across the top. And then if you did drop them on a living room carpet, you would actually be able to put them back together quite easily. So going forward a bit, in 1975, Frederick Brooks did an analysis of lots of projects. And the outcome there that I took away was that if you have a project that's doing badly, going late, if you add more people to it, it will actually turn out even later. And this is to do with software complexity. Going forward a bit to one of the first jobs I worked on, which was for a bus company, we had quite an interesting system when the customer came back and said, it doesn't work. We can't get onto the system for 20 minutes. This was going back way before GSM. This was MPT 1327. So there was a transmission protocol where you backed off if you collided and tried again with a random time. And we say, well, what's happening? And they said, well, everyone has a meeting in the morning, and then we all go out and we all turn on the engines, and it takes 20 minutes before we can actually use the radios. And it turned out that we were using a pseudo-random number generator. But every collision, they all backed off, and they chose the same random number, and they transmitted again. And this happened again and again, and it was about 20 minutes when they finally were all working. Anyway, going forward a little bit further, one of the items that really struck me was Clifford Stoll's The Cuckoo's Egg. I don't know if many of you have come across this. Anyone? Say? Basically, he tracked down a spy who was hacking through an American university system and using it as a base to hack into military, stealing secrets because most of the military were still using default passwords at that time. And then they were going on to, he was selling the secrets to foreign countries, and he was actually operating on the other side of the world using a 1200 baud modem. Anyway, the next thing that struck me was I worked on a railway system, and again, it was quite early on. Did a locomotive radio unit, and that had a complete size, 64K of ROM was the entire system, the entire radio system. Whereas nowadays, quite often a secure boot will actually take 64K, and if you're going post-quantum, you may well find that a public key may be that size. So going forwards, by 27, I was basically using secure boot on all the projects we were using. But the main problem there was that it wasn't a hardware-based secure boot, but it was secure boot. You could only actually use software that had been signed. but you needed the hardware base. And that came in, and then finally, around about 2014, I worked on actually a small cell system for telecoms, and we changed the underlying hardware 3 times. So the product looked exactly the same on the face of it, but underneath, the security solution had to be completely different. And it was like putting a different engine in, maybe a gas, maybe electric, maybe diesel. The entire engine was changed because different manufacturers had different methods of actually securing their hardware. And going forward, more recently, we've got the consumer, we've got the UK consumer product advice, we've got GDPR coming in, we've got various laws coming through, guidance coming through, and the CRA. So, challenges of globalization and connectivity. So, many of the connected systems we have now have got operating systems, and that means that if you can get in there, you can do what you want. And that's what a hacker is trying to do. And they now can be, because you're connected, they can be anywhere in the world. Your privacy data now needs protection, so you need security because you've got privacy data. And that's come in. We've also got an extended risk well beyond the immediate device that you're dealing with. If you're the weakest link in a bigger system, if you go down, then the whole system can be taken down with you. An example there, for instance, was there was a internet-connected kettle that had, I think it's been reported in the news, where it was basically had a default password, and anyone driving by could actually log into your Wi-Fi and get your password because the kettle was giving it to them. So there's extended risk well beyond your immediate IoT device. And then the other difference, because early on, there was no security. Early part of my career was absolutely no security at all. But now there are sophisticated hacking tools out there. Organized government efforts often create hacking tools that are very, very good, which is great as long as they're doing the right thing. But if they're hacked and the hackers get hold of these tools, then we've really had it. We then come to Salami. I don't know if you've heard of Salami. It's systematic approaches to learning algorithms and machine inferences. Basically, it's AI. Salami is a word that's a lot safer. Is AI going to take over the world? Is salami going to take over the world? It's a lot nearer the truth. But the problem with AI is that anyone who can use it can actually ask it to basically create software that will hack into your systems. And they don't need to understand how to hack. They just use the OpenAI to hack into it. So this is a new challenge. We've got to face this. However, there are now many securable chips available. But again, security should never be an afterthought. And that's come through my career again and again. It's been very difficult early on to get people to put security in. But now we've got a chance. We've got best practice for security coming through. So we've got the UK Code of Practice, which is great because we were well ahead there. With the 3 red ones now, PSTI, no default passwords, vulnerability disclosure, and keeping software updated. Etsy's got a very, very similar system. Maybe understood more by the rest of the world. They look very, very similar. They are very, very similar. And then the Security Foundation's assurance framework, which I think is really good as a security expert, I was amazed at what they've done there. You decide your class, and then you can work out all the things that are appropriate to you to that level for that device. So, the challenge. My challenge was to help people produce a secure system. We have a problem that there are not many security experts available. So you've got to try and package it up so that many companies can use it without having to have the security expert. And one of the problems we have is that security is not just technical, it's also a process. So these are my top 9, one less than the previous. So 9, and we'll go through each one in turn. So first of all, if you're going to create a secure product, you're going to need to do yourself a threat model. You need to decide what you're protecting, what type of defense do you need. So, I mean, Roman soldiers were under attack from various arrows, frontal attack with swords. So they had some sort of defense where they used shields above and beside and so on. That would be good in Roman times, but now with machine guns, that would be absolutely useless. But your threat model is a living document, and again, once you've done that, you can then gauge a category and use the IoT Security Foundation's assurance framework to work out what you really need to do. So the second item was the device root of trust. Now, this is incredibly important. You need to select a device that has a true random number generator. If you don't have a true random number generator, you're stuck with the buses. You will be hacked because it's not truly random. You also need a unique identity per device, and also you really need a unique private key. You're going to need secure memory and secure processing, and you're also going to need sufficient memory and levels of privilege. And one of the things you also need was going to be a device certificate to prove this device is who it says it is. And you're going to need secure boot validation. So this is all pretty standard stuff, but you need it. Looking at the actual certificate chain itself, you will need to basically, on the left we have the device with a key pair where you've got a private key and a public key. And the public key will be built into a certificate. You need to get that certificate into the device, but it also needs to be signed by your intermediate signing key. And that key on the right is your most sensitive key in your entire system. It belongs to a chain of certificates. Now this PKI chain, I'm a PKI expert, but most people haven't a clue what PKI means. Basically, you don't need to go to a second party to be able to create such a PKI. You can do this yourself. It is quite easy. The one thing is you need to keep your keys secure. You're going to need secure boot, but you're also going to need to update it. You're going to basically have to update your application software. So you're going to need the ability to install new applications and also potentially encrypt them. And you're also going to, once vulnerabilities hit you, you're basically going to need to prevent someone from reinstalling the one that's vulnerable. So you need to lock down your system with secure boot, with anti-rollback. And yeah, everything's connected, so you're going to need cloud connectivity, maybe Azure or AWS and so on. And these will use TLS or IPsec. And they will all insist on client authentication. And again, you can use your PKI certificate, your device certificate, to connect and straight through to the cloud system. and you put your intermediate certificate into the cloud as a trusted certificate configured. And then one thing you can do, which you can perhaps get back to if we've got more time, service certificates. Ideally, you then replace your device certificate with a service certificate for operational purposes. So one of the most important items is zero trust manufacturing. The manufacturer will actually create your private key and your device certificate and lock down your device, use your PKI signing key. And you cannot reuse, you don't want them to be able to reuse your keys or overproduce. So a subcontracting security appliance needs to go into the factory. Then the next bit is to isolate developers. You've really got to prevent your developers from using the final production system. So you need to isolate them using maybe, but you do want them to be using the final software. You just want them to be using different keys that are incompatible, different PKI. And then finally, IP protection. You may need to encrypt to actually protect your IP. And we've got, going forward, vulnerability disclosure, where you've got to publish your contact details for vulnerabilities. You've got to monitor your open source vulnerabilities. You need a system for vulnerability handling. You need anti-rollback software and your end-of-life notice for your product. So what I've been working on the last 7 years is a system where we basically provide isolation of developers. We provide device root of trust, secure boot, IP protection, infrastructure certificates and zero trust manufacturing, and secure cloud connectivity. And although IAR Embedded Trust will do all this, we can also allow people from not using our supply chain to use the zero trust manufacturing as well. So I'm in the Cambridge office of IAR, which used to be Secure Things, which was set up by Hayden Povey about 7 years ago. And our mission is to secure the products of today and the innovations of tomorrow. So have we got time for questions?